So the triangle inequality theorem. Before we left, I said, think about if any three side lengths would make a triangle. So on the sheet I have these little tiny pieces of paper. We're just going to do a few together up here, and you're going to see whether or not it will work. Now this isn't super scientific because, again, I'm just using pieces of paper. It says, will a 2, 3, 4, a 2-inch, 3-inch, and 4-inch piece make a triangle? Let's see. So if you lined up the corners, yes, it would make a triangle. Okay, so it would make a triangle. And plus it's right there. It says, copy the table below. You don't need to. We have a copy for you. And it's, sorry. I'm trying to get stuff here. Will it make a triangle? Yes, it will. Try to build a triangle with the different combinations of given side lengths. If it can be made, enter yes in the table. If it cannot be made, you enter no. So a 1, 2, 3. Let's take a look. Here's a 1, a 2, and a 3. So if I put the 3 here, maybe it'd help if I move the paper so you can see it better. 1, 2, 3. Let's see. Does this look like it's going to work? So even if I tried to like narrow them down, well, what does 1 and 2 equal? 3. So it doesn't look like it's going to work. So this one's a no. So in your chart, you fill in no. The next one, 4, 5, 8. Nope. Here's a 5. Where's a 4? Like I said, these are all like mixed up in here. Here. 4, 5, 8. So here's 8. Here's a 4. Here's a 5. All right. Yes, it will work. We don't have to be super precise. It's obvious when it'll work, and it's obviously when it won't.
Will we have to do this?
No, we're just going to fill in the chart really quickly. 5, 6, 7. We'll do a couple more together, and then I'm going to have you guys see. So on the chart, the next one's 5, 6, 7. What do you think? Just 5, 6, and 7. Do you think it will?
Yes.
Yes. Okay. 5. And yes, all of it won't fit, but yes, it made a triangle. So the next one's yes. What about a 1, 4, 5? Why no? Why do you think no?
Because 1 plus 4 is 5.
You said 1 plus 4 is? 5. So what do you think will happen? It'll just, whoop, it'll just fall.
No.
You are correct. All right, what do you think about a 3, 5, 6? Yes, it will. What about a 2, 3, 5?
No.
See, you guys already are catching on. It's a no. 4, 5, and a 7?
Yes.
Yes, it will. What about a 2, 4, 6? No. What about a 1, 2, 4? Let's try it. 1, 2, 4.
Wait, what was 2, 4, 7? Wait, I thought it was 2, 4, 6. No.
No.
I thought one was supposed to be on the left.
It won't focus, but you can see the general shape. No, it will not. Because these two can't. If they have to stay their corners here, they can't. They'll never end up making a triangle. So this one's no. So let's see. Let's give an example of sides that did make a triangle. Well, we had a 4, 5, 8 made a triangle. And what's another one? A 3, 5, 6 made a triangle. Okay. Now let's look at things that did not make a triangle. A what, honey?
1, 4, 5. 1, 2, 3.
A 1, 2, 3 did not. A 1, 2, 4 did not. A 2, 3, 5 did not. So what I want you to do is it says using the table, find the sums of the lengths of the first and second pieces. Really, I want you to look at the two shortest pieces, not just the first two. The first two, though, the way they have the table listed, the first two are always the shortest two pieces of the thing. Like the longest piece is listed last. So don't think of it's the first two numbers. Think of it's the shortest two out of the three. So look at the sums of the first two numbers and see how it compares to that third, the longest length. And then what do you notice about the ones that worked and what do you notice about the ones that didn't? And then answer 3 and 4. And I want you to work with this like 7 minutes with a partner, okay? And talk about these. So you're going to, one more time, you're going to add together the first two, which are the two shortest lengths, and see how it compares to that third piece, which in our table is the longest length. And I want you to see what you notice about the ones that do make a triangle and the ones that did not make a triangle. And write that here, answer number 3, and then see if you guys could come up with what the rule is. Okay, because this is a theorem. All right, so go ahead, I'm going to do about 7 minutes, and then we'll come back together. Okay, so what did we notice? I've already visited a couple groups, and they both got it. So it says, using the table, find the sums of the first and second pieces. Just notice, in their table, the first and second pieces are the shortest. So when you add the shortest two lengths together, what did you notice, Janaya?
The shortest?
Tell me what you told me.
If the number is higher, than like the original one, then it's again.
So, can you repeat what she just said, Brighton?
Ma'am?
Did you hear what she said? No? Who can repeat?
I heard a little bit of it.
Okay, go ahead.
I can't repeat, but I do know what.
Okay, go ahead.
So basically, if the first two numbers equal the third number, it's a no.
Correct.
But if they equal like over it, it's a yes.
Correct. What if they equal under it?
It's a no.
It's a no. You guys have got it. So.
That's what I do.
So do you think it's possible? So in case that they couldn't hear on the in the video, you guys said if you add the two shortest lengths, it has to be greater than that third length in order to make a triangle. If when you add the two shortest lengths and it's less than or equal to it, it will not make a triangle. So something like that for number 2. So knowing that now, would a 2, 2, 4 make a triangle? No. And you guys picked up on the pattern very quickly. So why won't it? The two shortest lengths do not add to, this is really bad grammar, to be greater than the third length. Something like that. I mean, that's really bad grammar, but. So the rule is actually on the back of the page. It says, the triangle inequality theorem, and this is on your study guide and on your test. Your study guide is Wednesday, your test is Friday. States that the sum of any two sides of a triangle has to be greater than the third. Now they say any two. If you just add the two shortest lengths first and compare that to the longer of the three lengths, or the longest of the three, you'll know right away. Because if you look at it, well, let's find a no. Is 2 plus 3 greater than 1? Yes. Is 1 plus 3 greater than 2? Yes. Well, is 1 plus 2 greater than 3?
Yeah,
No, they're equal. So if you just do the two shortest ones first, because the other two may work. So if you just pick the two shortest side lengths first and add them, it has to be greater than that third length. Can't be less than, can't be equal to, but you guys figured that out. Okay? So, now you're going to go through this page. Could a triangle be drawn with the given side lengths?
Can we pick more than one?
No, it's a yes or no. It's not multiple choice. It's yes or no for all of them.
Maybe no.
Okay. So let's just do 1 through 6 on here. All right.
Is this going to be on homework?
Oh, actually, no, let's do the, I know what we'll do. What we'll do is we'll do 1 through, yeah, let's just finish this page and we don't have to do that. Okay? Let's just finish this page. We have about 15 minutes, so that's a minute per problem. Let's finish this, and then we don't have to do the book work, because quite honestly, that'd be the third day of you doing that same stuff, but this reviews that. If you look at number 7, it says, could a triangle be drawn with the given angle measures? Well, how many degrees in any triangle? 180. So if these don't add up to exactly 180, what's the answer to be?
No.
See, so this reviews still what we would do there. Does that sound good? I think that's a good deal. Okay, so just finish this, 1 minute per problem, and we won't have homework, even though I'm sure you're just going to be sitting inside tonight figuring out how to raise it.